Good morning, students. I'm your mathematics teacher. My name is Rajneesh. Okay. From now onwards, I'll be teaching mathematics for you. I'm sure in the last class, in the last video, Hemlata ma'am have started already about these circles. What are the different things you know about the circle? In a circle, this is the center, and what do you call this? Radius. And this one, diameter. Now, how do you define a radius? Radius is nothing but a line which starts from the center of the circle to the circumference of the circle or to the any edge of the circle. I can tell you this is radius, this is radius, this is radius, this is radius. Similarly, what is the diameter? Diameter is nothing but it is again a line segment joining from one edge of the other to the other edge passing through the center. This is a circle. From this point you pass to the other, but it has to pass through the center. Only then it is called as diameter. Okay? Now this line, I cannot call this as a diameter because this line is not passing through the center. A line which passes the center from one edge to the another edge is called a diameter. And what is the relationship between a diameter and a radius? Radius is always half of diameter. Understood? That is the basic things of a circle. Now, for example, I have a circle here and I have a line here. Which are the different possibilities we can relate the line and the circle or a touching? See, I can either keep a circle and a line like this, and I can do like this, or I can touch it on the edge. Three things. One is either it is not passing or touching the circle. Second, it is passing through the circle. Third, it is touching the circle and passing. These are the three options where a line can intersect or it will not intersect. Now, I have a circle like this. If a line is passing like this is called as secant. If it is only inside, this is called as chord. All these you might have learned, I guess. Correct? And this touching tangent. Now in this chapter, we are dealing with this tangents. Okay? Let's see a detailed thing about the tangent. Now when you have a circle and a tangent, okay, tangent. Now this line is called point of contact. To this particular point, how many lines we can draw? We can draw only one line. Correct? But how many tangents we can draw for a circle? We can draw n number of tangents. But to this particular point, I can draw only one tangent. Remember that. To given circle, I can draw n number of tangents. But to one particular point, you can draw only one tangent. Now, I have a circle and a diameter. How many tangents I can draw for this diameter? Diameter is nothing but this one. That means to this particular point I can draw one. This particular point I can draw one. So that means for a diameter I can draw two tangents. For a point on a circle, you can draw only one tangent. Remember this always. And to a circle you can draw n number of tangents. Now what is the relationship between a circle and a tangent? Now if I draw a tangent here, this point is the point of contact. You can always remember one more thing. From the point of contact, if I join the center of the circle, from a point of contact, if I join center of a circle, the angle to form is always 90 degrees. Understood? If I draw a line from the center of a circle to the point of contact, the angle formed is 90 degrees. Remember this. Now, there is one important theorem based on tangent and circle, and it is called as external point theorem. External point theorem. Now, what this theorem states is, and this is very important theorem, remember, this is very, very important. This theorem you will get on for the board compulsory 3 marks. 3 marks compulsory you will get. What it says here is, you have a circle, and you have here A, here B. Okay? When you join a tangent like this, okay? When you draw a tangent, this is P. When you draw a tangent like this, these two tangents, which is AP is equal to P. Okay? When you draw a tangent, okay, let me just check this once. Okay. Now, as I told you, this is point of contact, and these two, AP and PB, these are called as length of tangent. What is length of tangent? From the point of contact, this point is called as, this line is called as length of tangent. The length of a tangent drawn from the external point. This is circle, right? This is internal. This is external. This is the external point. If I draw a tangent like this, and from the same point, I draw one more tangent, the length are equal. That is what they are telling. If the length of the tangents drawn from the external point are always equal. That is the statement for the external point here. What is the statement? The length of the tangent drawn from the external point are always equal. This is the external point theorem statement. The length of the tangent drawn from the external point are equal. So this statement we have to prove. What do we have to prove? They are telling that this length is always equal when it is drawn from the external point. So that means we have to prove this. To prove AP is equal to P. To prove this, no, we require a triangle. See, whenever you have to prove anything, no, we from even in the last year we started proving based on the triangles. So until this we don't make it a triangle, we cannot prove. What we can do here is, this is center, join this. and you join this. Now we get two triangles. This is the first triangle. This is the second triangle. So what is the construction we have to do? Construction. Construction is join OA, OB and OB. This is two steps. First is the statement to prove construction. Next one is proof. Now in the proof, we are taking two triangles. Which are the two triangles? In triangle AOB, AOB and DOB. These are the two triangles. Just before sometimes, I told you that when you join a line from the point of contact to the center of the circle, the angle formed is a right angle. Correct? In this, which is the point of contact? This is the point of contact. This is the right angle. This is the point of contact. This is the right angle. Done with this? Any doubts in this? Now here in triangle AOB and BOB. Now, what kind of a triangle are these? It's a right angle triangle. Can you tell me which is the hypotenuse here? See, hypotenuse is always opposite to a right angle, that is 90 degree. So this becomes the hypotenuse. This becomes the hypotenuse. Correct? So we can start with angle A is equal to angle B is equal to 90 degree. Done with this? Second, OP is equal to hypotenuse common for both triangle. For both triangle. Is this correct? Next one. Can I tell OA is equal to OB? Can anyone guess why? I am telling this line is equal to this line. Why both are equal? Because they are the radius. What is the plural of radius? Radii. They are radius, that's why they are equal. Now what is the criteria for RHS? The criteria of RHS is it has to be a right angle triangle. It is right angle triangle. Hypotenuse has to be equal. It is equal. And then one side has to be equal, which is OA and OB. Therefore, as per RHS, triangle AOB is congruent to triangle BOP. Now if these two are congruent, which are the corresponding sides? I can tell this is a corresponding angle, corresponding angle. This is corresponding angle, corresponding angle. Corresponding side I can tell AP is equal to BP. This is fine. CPCP. If at all, tomorrow if they ask you one more question with the same concept, prove that AOP is equal to BOP. Again you have to do the same thing, and in the end you can write AOP is equal to BOP. Why? Because CPCP. What is CPCP? Corresponding parts of congruent triangles are equal. Understood? And this is very, very important. Okay? I just want to ask you one more thing. See, this is a quadrilateral. Remember this. This is a quadrilateral. Now in this quadrilateral, I have here 90 degree, right? This is also 90 degree. Correct? If these two are 90 degree, how much this angle and this angle has to be? This is 90 and this is 90, which is 180. So in a quadrilateral, you have total of 360. In 360, if you remove 90 and 90, you are left with 180. That means when you add this angle and this angle, you have to get 180. Remember all these things, because All these you may get in MCQs. Now this is about the theorem of a circle, and it is very, very important. See, in this class, I may not able to complete this chapter, but I will do few important problems. Whatever remaining, we can either continue in the next class or in an interactive session. Now with this, there's one more important problem. Now in exercise 4.2, if you see exercise 4.2, there is a problem. Angle POQ. They are asking that POQ. They are asking this angle is POQ. How much is this? Just before I told you, right? When you add these two angles, you have to get 180 degree. If this is 110, this is 70 degrees. Remember this. Okay, there's one more problem. A quadrilateral, 8-1. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. Now in this, what I've done is, you have a circle like this. Again, all these problems are based on the external theorem. External theorem. You have to focus more. See here, if you take this circle, this is a circle, right? This is a tangent. Just now we proved, right? If you have it like this, it is the same thing, but it is very small. Always remember these two lines are equal, because as per the external point theorem, the length of the tangent drawn from the external point are always equal. Now this is the external point. That means AB is equal to AS. You can directly write solution. AB is equal to AS. Why? External point theorem. External point theorem. Either you can write external point theorem, or you can mention the length of the tangent drawn from the external point are always equal. This is done. AP is equal to AS. Next do BP is equal to BQ. Same thing. BP is equal to BQ. Done with this? See, first we do to these two. These two. Now you take these two. CQ is equal to CR. The reason is same. And then DR equal to DS. Understood? Now here, if I add AB and PB, I will get AB, AB and BB. AB I'll get. CQ and BQ, CQ. Okay, did we write all? If I add this one, on the left hand side I have to get AB and CD. With these two I get AB. Now where is CD? CD. Do I have CR and DR? CR. Okay, interchange this one. CR. CR is equal to C. Now add all these things. You get AB plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. Done. What is AP plus BP? AP plus BP. I can write AP, right? CR, I can write C equal to ASBQ. Okay, BQ is here. Now you take AS and DS here, DS. This together, I can write AP. And these together, I can write C. This is what we have done. Okay, this is now. Okay, this is about 8th problem. Let's see one more. Now I've just done a few important problems on this chapter. Okay, and let's see in few more classes we will try to solve more problems based on this. Okay.